Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, Senior 1 students. How are you? Alan is my name, and we shall be interacting in chemistry lessons. I hope you're fine. So today we are going to be looking at Unit 13, which is about oxygen and its properties. It's under the subtopic of oxygen and oxides. Oxygen and its properties, that is what we're going to be looking at. But before we go directly on to today's work, I want to give you a highlight of what will be making up this unit, and different objectives we are to achieve. I'm giving you this for you to go ahead and read prior or read ahead of what we haven't covered for you to remain equipped and understand more during the lesson time. In this Unit 13, we are going to look at methods and materials of preparing and testing oxygen in the lab. We're going to look at the physical properties of oxygen, going to look at the chemical properties of oxygen gas. Then we see how, when it is prepared, what method is being used to collect that oxygen gas. Then we relate the method with other gases, like carbon dioxide gas, which I'm pretty sure that is not new to you. You looked at it even in your primary level during the science lessons. So then we look at the uses of oxygen in our day-to-day lives, together with the ozone layer in the atmosphere. Ozone, I think you've been hearing the word ozone depletion or ozone layer. So we are going to be looking in details on what is exactly is ozone and what makes up the whole ozone layer in the atmosphere and what is its use. So again, I implore you, if you can read ahead of what we covering so as you get complete comprehension. That being said, we are going to be having a few objectives. One is you should be able, by end of studying this unit, you should be able to prepare and test oxygen gas by yourself, then show how oxygen reacts with other metals, and show how oxygen supports burning. Then write equations involved in the reactions of oxygen with other elements. Then appreciate and recognize the importance of oxygen in our day-to-day life, like welding and so on. Then develop a sense of environmental protection against depletion of ozone layer in the atmosphere. So you see, the objectives are connected to the unit outline as I highlighted it onto you. So in the sense that even when you go and do your personal review or personal reading, you can evaluate yourself to find out if you've really attained or achieved the objective. The image you see, that is a welding, that is the person welding using oxygen gas. We shall see that when we come to the importance of oxygen in our day-to-day life. Well, that is a bit of the introduction and what encompasses the whole unit. Now, we are going to our lesson 1, which is a small part of the whole unit. So, dear students of Senior 1, our lesson 1 within Unit 13, which is about oxygen and its properties, involves introduction or information about oxygen, then how is oxygen prepared in the lab. Possibly later on in the other lessons, we are going to actually prepare it, as you see, then we test it. But right now, we are going to make a quick background of what it is and how it is prepared. Being the first time I'm interacting with you, let me give you a quick highlight of what is going to make up this lesson. And even in the subsequent lessons, we are going to be having this illustration. Take on the slide. We are going to be looking at what is making up the lesson for today, and that is called what we are focusing on. Focus on makes up the lesson for today. Then the key terms for you not to miss in that lesson then are also always included. So a quick highlight. In today's lesson, we are going to look at the natural occurrence of oxygen. Do we have oxygen naturally occurring, or it is artificially manufactured? If it is naturally occurring, in which form does it exist? So this is what we are going to be looking at. And what are those materials and methods that can be employed to prepare oxygen? So that is what we are going to look at. So the key terms, one is photosynthesis and another is respiration. These terms are not new to you, I'm pretty sure, because we look at respiration in biology. It is actually Unit 1 biology, where we are looking at characteristics of living things. So respiration ideally is the taking in of oxygen, and it is used to break down the food that we eat to give us energy and release other wastes like carbon dioxide. Photosynthesis, you looked at that in your primary, which is the process under which plants, green plants, manufacture their own food from carbon dioxide, water, and in presence of sunlight. So those are, we shall connect them in respect to oxygen. So I hope you're still with me, and our objectives for this lesson. I want you not to confuse the objectives I gave you at the first were for the whole unit. This lesson has two main objectives which we are to achieve. One, you should be able to state ways in which oxygen gas is added or removed from the atmosphere. Then mention the precaution that should be taken and demonstrate how oxygen gas can be prepared in the lab from hydrogen peroxide as one of the material. So I'm giving you this information to help you understand the lesson content. All right, now let's start on the lesson content, natural occurrence of oxygen. My dear students of Senior 1, let me ask you, when someone talks of oxygen, what comes into your mind? When someone talks of oxygen, what comes into your mind? Now I'm giving you 30 seconds to think. What comes into your mind? All right, our 30 seconds are over. I hope you have an idea. To me, what comes into my mind is oxygen is used to produce fire for welding. We use it to breathe. It is used in our breathing. We take it in. Even oxygen has two atoms as O, two atoms together, combined. So also this comes into my mind. So, but my emphasis will be much more on the air we breathe in. Oxygen is the air we breathe in. Take a close look at the slide. What do you see? What do you see? That image. Yes, these are three people underwater. They are actually called divers. What do you see that is very common to them? You see this oxygen tank. Oxygen tank. So they are using oxygen. When they are in water, they have to carry oxygen to help them keep breathing. Because we don't have gills to help us use the oxygen that is existing in water. So in that case, you can see the aspect of how oxygen is useful. For breathing, as you can see, for us to remain active, we need to be taking in oxygen. And if we go to areas where there is no oxygen available for us to breathe in, then we must carry our oxygen. So this brings me to aspect of where can we find oxygen. You're already seeing me that where I am, I'm breathing because here air is having oxygen. So oxygen is actually everywhere, and it makes up about 46% of the Earth crust. So you see it is everywhere. Even in water, it is there. But as I said, for us, we don't have gills to use that oxygen that is dissolved in water. But it is also there. We also have oxygen in the atmosphere, and that makes up 21% of the air in the atmosphere. That's why, as you can see me, I'm breathing oxygen without any help. I don't have the oxygen tank because in air here there is oxygen which is separate. I can breathe it in. Even in our bodies, as we take in oxygen, our bodies also contains oxygen. About 61% of our human bodies is oxygen. So you see, oxygen is almost everywhere. Like as I said, when one talks of oxygen, what comes into my mind, other than breathing it in, is its structure is O2. Big O with a subscript 2, or a 2 on the lower section. And that is how oxygen exists. So that is about the natural occurrence of oxygen. Yes, it exists naturally. Now I will ask you a question. What are those processes that increase the amount of oxygen in the atmosphere? And what are those processes that take oxygen out of the atmosphere? Think. What is that thing that brings in oxygen? Remember the key terms I gave you at the start? Now I want you to connect them, those key terms. So what are those processes that bring in oxygen to the atmosphere and take out oxygen from the atmosphere? That's your question. I'm giving you 10 seconds. If you've been following, you must recall those key terms. So those are the two processes that we to look at. One, photosynthesis. As we said, photosynthesis is a process whereby green plants use sunlight, carbon dioxide, and water to produce their own food, and in the process they give out oxygen. So as they give out oxygen, its amount is increased in the atmosphere. But because for us we don't make our own food, we take up the oxygen that has been released by plants under a process called respiration, giving out carbon dioxide gas. So respiration by animals takes up oxygen from the atmosphere. Photosynthesis by plants releases oxygen into the atmosphere. But it's not only green plants. There are other small organisms. Some, like bacteria, they also release oxygen because they can carry out photosynthesis. The algae, they also can carry out photosynthesis, and so they release oxygen to the atmosphere. Now you see our two terms, they are very, very crucial because without photosynthesis, we may not have the opportunity of living more because the air in the atmosphere will be exhausted. So we need photosynthesis to keep bringing in oxygen in air so as we can keep using it. So do not cut those trees and flowers in your compound. Please leave them, water them so as they can keep growing as we keep getting oxygen. So that is about its natural occurrence and how it exists. Now let's go to how is it prepared in the lab. Yes, it is available within the atmosphere, we can see it, but can we prepare it in the lab if we want to use it instead of using what is in the atmosphere? Yes, we can prepare oxygen in the lab. And there are many methods with many materials that we can use. But the first method is called catalytic decomposition. When we're talking of a catalytic, we are talking of a catalyst. You're breaking something in presence of a catalyst. So we break hydrogen peroxide in presence of manganese dioxide as a catalyst. We break potassium chlorate in the presence of manganese dioxide as a catalyst. Let me pause and ask you, what is a catalyst? What is a catalyst? And don't say you haven't covered it, you looked at it. What is a catalyst? So a catalyst is a substance. Now let me write that term. Catalyst is a substance which is used in small amounts to make the reaction become faster. That is a catalyst. In this case, as we produce oxygen from hydrogen peroxide, we use manganese as a catalyst. Let me try to bring this in real life. I know you students, when you are at school and you are, maybe you are playing, you always cheer up some of the players who are inside the field. Let me call it football. You're playing football. Some people on the side, they are cheering you. Yes, yes, go ahead, go ahead. As they are cheering, they are giving the people in the field playing more energy, more intensity. So in that case, the people cheering are acting as catalysts because they are giving the people playing more energy and enthusiasm. So even in the chemistry, when you have a reaction occurring and you add a catalyst, it makes it very fast. So that's the first method. Method 2, we heat group 1, we heat nitrates, mostly potassium nitrate or sodium nitrate. Those are the ones of group 1. When you heat them, they will give you oxygen. And the third, we heat lead dioxide. It also produces oxygen. But this lead is poisonous, so we do not advise any person to be using lead dioxide to produce oxygen. We are going to be looking at these methods, each separate, and we even go deeper and see what is required. Now, let's look at preparation from hydrogen peroxide. That is hydrogen peroxide. H, this is its formula, so it is hydrogen, oxygen, like this. So there are 2 oxygen atoms and hydrogens. So what do you need to prepare this oxygen gas? Like as I told you, we shall first make a highlight of it, then another time we shall prepare and we test it. So that I give you a word. So what do we need? You can see you need the hydrogen peroxide. Take a close look at the slide, please. Hydrogen peroxide in the fissile funnel and manganese as a catalyst. So when you mix these two, then they give you the hydrogen gas. A few things you need to take, that is the precaution. The precaution is this hydrogen peroxide we are using is very dangerous. It is very oxidizing, so you need to handle it with care. If you pour it on someone's body, the skin will be burnt, so you have to use it with care. That's the first precaution. The second aspect is, in this case, manganese oxide, as you see, dioxide, is a catalyst. It makes the reaction become faster. Then you collect, when you mix these two, hydrogen peroxide and manganese, the gas will be produced we collect it over water, which we call it downward displacement of water. So this water in the gas jar will go down as the gas goes on top of it. So you'll have your oxygen here, and that is what we call downward displacement of water. Why do we do that? It's because it is soluble, it is slightly soluble, meaning it will go in water and it come out of water. That is what it means by being slightly soluble. So it does not completely get consumed by water or dissolve in water. So the equation for that reaction is, you can see, please, I want you to take note on how to write the equations. Practice writing equations. You covered that unit of balancing equation, but it is best if you keep practicing writing equations. And in this way, this is the equation for the preparation of oxygen from hydrogen peroxide. So let's quickly look at one more, that is preparation of oxygen from potassium chlorate. That is the setup. Take a close look at it. Take a close look at it. And as usual, it's always best to take the precaution. Let me first give you the precaution, then I illustrate what is happening. The precaution is we are involving heating. You see, this is a Bunsen burner producing heat, which will heat the potassium chlorate in the presence of manganese dioxide as a catalyst. So because we are involving heat, we can't play or joke with heat. This heating must be taken care of seriously and gently, so as we don't burn the lab and burn our fellow students or the people we are carrying out the experiment with. So what happens is, as you mix potassium chlorate with manganese dioxide as a catalyst and you heat, the gas will come out. Why do we add this catalyst? Is when you heat potassium chlorate, the reaction is slower, not very fast. So we need to add a catalyst to make it faster. Then you will have your oxygen, which is also collected by downward displacement of water. And that is also the equation. That is also the equation. Please take note on how to write the equation. As I said, practice them as much as you can. Lastly, commercial preparation of oxygen. Yes, in lab we prepare oxygen, but not all the oxygen that is being used on commercial scale is from the lab, because in lab you prepare very small to use. But if you need large quantities of oxygen, then a different method is applicable. What do I mean by large quantities of oxygen? Like the oxygen used in inhaler by different people, the oxygen gas used in hospitals, what we call the intensive care, or you normally say that someone is in oxygen in the hospital. So that oxygen that it is sealed and enclosed in the cylinder, it is in high amounts. To get that big volumes of oxygen, it requires doing it from a large scale, and that is by fractional distillation of liquid air. I'm going to pause a little bit. Fractional distillation, you already looked at the methods of separating mixtures and components. Air is a mixture made up of nitrogen, oxygen, and other noble gases. So these components of air have different boiling points. Oxygen, for instance, when you get air and you make it a liquid, it will be a liquid with oxygen, nitrogen. Oxygen has a higher boiling point than nitrogen. You see my highlighter? Nitrogen is -196, oxygen is -180. 83 degrees Celsius. This is bigger than this. So when you heat this liquid air, nitrogen, because it has a lower boiling point, it will easily boil out. It will become a vapor, so you remove the vapor and remain with liquid oxygen. And that is how they get the liquid oxygen in the different containers that we use. So that is the highlight. Let's quickly summarize up what we've gone through in this lesson. 1, oxygen makes up about 21% of air in the atmosphere, and we use oxygen in breathing or in the respiration. So as we take in oxygen from the atmosphere, the amount of oxygen in the atmosphere reduces. Good enough, plants, when we take in oxygen and release carbon dioxide, plants use carbon dioxide and release oxygen back to the atmosphere. So the amount of oxygen in the atmosphere is kept constant by removing it by us human beings, and plants bringing it back. Lastly, you can prepare oxygen in the lab by decomposition of hydrogen peroxide in presence of manganese dioxide as a catalyst, or potassium chlorate in presence of manganese dioxide as a catalyst, or from heating group 1 nitrates. That is it for today, and it is best I leave you with the exercise to test your understanding. So this exercise is about preparation of oxygen in the lab, and you can read through it, practice it for you to see if you understood the lesson content of today. Thank you very much, Senior 1 students. I'm glad to have interacted with you. Please stay safe. I would wish to interact with you in the other lessons to come. Alan is my name. Bye.